What is up, everybody? John the Morgile here for another Flat Earth video. So let's get right into it. What you're looking at here is the current world record of distance landscape photography. The peak off in the distance, which is towards the middle left of the screen, is the silhouette of, and I'm going to butcher this, but it's Barre des Écrins, which is about 4,000 meters tall. But keeping that picture in mind, and I will pull it back up, but it is just a really nice picture from over 275 miles away. And we'll get into describing the picture a little bit, but before we do, let's just go right into the curvature calculations, because I know that that's what everybody is going to want to see first, especially the globe earth believers. So what you're looking at in this diagram is not to scale, but it's a breakdown of the geometry involved, assuming that the earth is a sphere with a radius of nearly 4,000 miles. Now, the observer height, as you can see going from left to right here, is about 1.75 miles, and that would make their ground horizon distance, or the point where the observer's line of sight should become a tangent to the curve of the Earth. And that's at about 117.8 miles, and again, that would be the ground horizon distance. Now, at that point of 117.8 miles, you can see that the line of sight begins to diverge from the quote-unquote curve of the Earth, and globe Earth believers say that everything beyond that point on the horizon should be obscured unless it is jutting up above the sea level. And so, as you can clearly see across the water, the entire mountain range, including the entire Barre des Écrins mountain, which is again towards the middle left of the image, and that would be the tallest peak. And geometrically speaking, that tallest peak should be buried by over a half a mile of curvature. Now, a few things going back to the image, and you can pause it on this if you want. Again, the total distance is 273 miles. The observer height is 1.75 miles, making the ground horizon distance about 117.8 miles, but we can clearly see that it is a perfect plane of water between the observer and the distant silhouetted peak, which is again a total distance of 273 miles. Now, just looking at this image a little bit more, it seems as if off to the left you can see, I guess, what appear to be either some sort of jetties or, I don't know, possibly waves. It's really hard to say, but it definitely looks like some sort of land or jetties or some sort of, little peninsulas or harbor area. It's hard to say, but it's sort of irrelevant. You can tell there's sort of two of those objects jutting out from the left-hand side of the image. And again, it's hard to gauge distance, but at some point beyond there, the line of sight would become a tangent to the curve of the Earth. And of course, that's what's claimed to be the horizon. Although what's interesting is the base of all that distant mountain range and the large peak, which is again over 270 miles away. That water forms a perfect plane all the way up to the horizon. And again, according to an assumed spherical Earth, your line of sight should become a tangent to the curve of the Earth, causing everything beyond that point to drop exponentially. And again, the tip top of those peaks should be covered by a full half mile and then some of that horizon line. And this is no mirage. When you factor in refraction, this it is claimed to work in favor of the globe all of the time at a standardized rate, which is just nonsense. Refraction certainly does occur, although it is a variable, and it will occur to varying degrees depending on conditions. And frankly, for people like the Metabunk site and the Metabunk calculator to claim something as ridiculous as standard refraction, that would be like saying standard rainbows or something, right? Because it's refraction is a variable phenomenon that occurs with light, and it's just really quite funny to me that globe Earth believers will set up their curvature calculations to include refraction to the maximum possible extent when, in some cases refraction doesn't occur, and if it does occur, it's very minute, something like less than 10% of the entire distance involved would be affected by refraction. And there are some pretty recent studies, unless I'm misinterpreting them, that refraction works in the opposite way as is claimed by Metabunk, at least some of the time under the right conditions. But to claim that there is something like standard refraction is really just quite absurd. The other reason that trying to figure in refraction into this sort of calculation is beyond asinine, because what we're actually seeing in terms of the distant mountain peak or any distant object jutting up above the sea level, for example, which is beyond the horizon, we're actually seeing perspective. And we would expect to see perspective, which again means the diminution in apparent angular size of an object proportional with its distance from the observer. In this series of images, I just want to show how an object, especially out at sea with undulating waves, objects such as a schooner, as it travels away from the observer, it doesn't actually shrink in size, but it apparently shrinks in size. And this is of course due to perspective, which happens inside the eye, doesn't actually occur in the real world. It's how we see the world is in perspective. And you can look into how the human eye works if you want to learn how perspective works. I've done videos on that. In this series of images, it shows how the angular size of this boat as it travels away from this observer as a sort of a side view. This is not to scale, but it shows how the angle, which while the boat is close to the observer is a very wide angle, you'd have to look up to see the mast of the ship while it's close by to you. And as it travels further and further into the distance, the more acute that angle becomes. And at a certain point, once the ship goes beyond the horizon or an object goes beyond the horizon, then the angular or the apparent angular size of the object is too small for your eye to render, and it will appear to merge with the ground horizon first and diminish from the top down, because of course you cannot see through the ground. So a little bit of background and perspective is probably necessary here. You can see in this image the representing something like railroad tracks, parallel lines running away from you off into the distance. The railroad tracks, when they're near you, will appear to converge on a single point. And this is one of the biggest fundamental misunderstandings that most people have in terms of perspective, is the whole vanishing point. And it is asserted by sort of Art Class 101 that all parallel lines in perspective will appear to converge at the vanishing point, which is not accurate. What is accurate is that any parallel lines which are equidistant from the observer will appear to vanish at the same point. Such as the rails, but if you add lines parallel to the original lines, which are further removed from the line of sight of the observer, then they will indeed vanish or appear to converge on the same datum line, but not at the same point. They will appear to converge more distantly upon the same datum line, but not at a single vanishing point. And then you can add even more askewed from your line of sight parallel lines running across the ground, and they would also appear to converge at the same datum, but not at the same point. And so that is how the actual operation of perspective works. This is indeed the cause, or the effect, rather, however you want to look at it, of the notion of parallax. So, in other words, parallax is caused by objects that are more distant to you appearing to travel at a slower rate than objects that are nearer to you, even though the two objects are traveling at the same speed. Or if you're driving through mountainous terrains at 60 miles an hour, the fence posts near you will appear to be racing by if you focus on them, although if you focus on the mountain in the distance, it'll appear to be essentially stationary. This is, again, what parallax is, and it's sort of the same thing that's going on here in terms of parallel lines and the actual operation of perspective. And this, of course, also applies to parallel lines which are vertically removed from your line of sight. So this image would sort of represent relatively nearby your line of sight parallel line, vertically removed from the ground. And then this image would represent, say, a 20-foot object, fairly well removed from your line of sight, vertically running parallel off into the distance with all these other lines, will not appear to converge at a single vanishing point as the blue lines, but it will appear to converge at that same datum at a further point along that datum line. So this is also the operation of perspective, what causes objects, even upon a perfectly calm water, such as a boat, to appear to converge bottom first with the horizon, is because, well, it continues to diminish in size equidistantly from top to bottom. However, once an object has traveled beyond your visual horizon, then the angle of the lines which are comprising your line of sight are all converging at the horizon. Anything near that line of sight will be indistinguishable in terms of angular size to your eye. This is why when you lose sight of a distant ship or a barge and zoom in on it, it will appear to have emerged from beyond the curve or beyond the horizon, and obviously this is just an optical illusion. But even when you can zoom in on ships far enough, if you don't get the inferior mirages or the fata morganas where it basically looks like the ship is floating in the air, that ship is of course on the water and the air is refracting, making it appear that way. But sort of besides the point. I just want to make it clear that most people misrepresent perspective by saying that all parallel lines converge at the same point, when indeed that is fallacious and demonstrably so. Just study parallel lines in nature. You can experiment with this yourself and confirm that it is indeed true. Not all parallel lines converge at the same point. It depends on whether or not they are near or far from your line of sight. That's how perspective works in all actuality. We would expect to see perspective, which again means the diminution in apparent angular size of an object proportional with its distance from the observer. That's actually what we're seeing in reality on the flat Earth, although we would also see that if the Earth was a sphere. So not only would you have the actual dropping away of distant objects, but you would also have the apparent diminution of objects as they gain distance from the observer. So you would have an actual, if the Earth was a sphere, you would have an actual vertical descent due to curvature, and you would have an apparent diminution in angular size of any object that is traveling away from you, especially beyond the horizon. This picture also demonstrates why we don't want to take curvature observations from tidal waters, especially not from on the shore. Also demonstrates a pretty interesting point. You can see towards the bottom of the image there's what appear to be waves coming in, so this would appear to be a tidal body of water, meaning it's affected by the tides, or meaning that it has essentially waves, high tides, low tides, that sort of thing. It is well known and accepted that water always finds its level, and that is very true indeed. However, that only is true if and when the water is completely allowed to be at rest. And so when you've got undulating tidal waters or large bodies of waters, what happens is that kinetic energy is sort of forced up the wedge of the shoreline, and so you get essentially non-standing water. There's pressure that builds up because of this kinetic energy, which travels as waves through the water. The energy of the body of water itself is sort of forced up that wedge of the shoreline, and you get a buildup of water pressure and therefore a false horizon. And so standing water is always the best possible place to do curvature observations, and even over frozen water, like over a lake that's frozen, which has been demonstrated very nicely. That's sort of that's way more ideal and proper in terms of scientific control, than doing curvature calculations or curvature observations over tidal waters. Now, even upon standing water, or even upon a perfect plane, the natural operations of perspective cause objects traveling away from the observer beyond the horizon line to apparently sink top first, but this is because the optical ground horizon is an obstruction to your line of sight, even though the Earth is indeed a plane, and the apparent angular size of the distant object will appear to sink down or merge down into the horizon bottom first, which is perfectly aligned to natural perspective. It has to do with the way that our eyes work, and if you do long distance curvature observations over tidal waters, it is ill advised, or possibly even being deceptive, because again, undulating tidal waters will form an optical horizon, and if you're out at the beach or in a oceanic environment, the thick particulates of evaporating water and such low to the sea level cause all sorts of optical hindrances, distortions, mirages, and so tidal waters are just simply not preferred for long distance curvature observations. The next thing that we're going to look at real quick is the subjective atmospheric conditions that we all live within. The atmosphere is, in the short range, totally transparent, obviously, but at certain distances the atmosphere becomes reflective and opaque, and this diagram sort of, poorly illustrates the point, but above our heads the atmosphere gets thinner and thinner and thinner with distance. However, when you're looking across the horizon or parallel to the ground, the atmosphere is at its thickest, and so the further you look through the atmosphere, it gets thicker much quickly as you're looking parallel to the ground compared to when you're looking straight up, and so you get sort of a convex lens of subjective atmosphere that basically follows you around wherever you go. And especially when observing celestial objects which are well outside of the atmospheric bubble, the inbound light waves coming from such objects are necessarily affected by this bubble, This is what causes the setting and rising of the sun, the moon, as well as the stars. Yes, perspective has a lot to do with it. However, the atmosphere seems to exacerbate or aid in the operations of perspective, allowing the sun to.
Hi Flat Earthers, this is Zach.
And this is Steve. In the previous video, we gave you an introduction on how the refraction in the atmosphere, or the atmosplane, was the solution to the various visual problems that were not working on flat Earth models. If you haven't watched that video yet, click on this link to watch it now.
Today we're going to explain a little bit more by showing you the star trails from different locations on the flat Earth. Many people thought that the video we showed before was not enough to prove that refraction is the reason why the sun rises and sets, and many others thought that refraction would make the apparent sun appear higher up instead of down. So to make this clear, let me tell you that what we did was add the atmosphere to the flat Earth model in Cinema 4D. And Cinema 4D made the apparent sun go down, not us. So if there is anything wrong with this, then it will be Cinema 4D's fault. If you disagree with the software, please send them an email and see what they will tell you. Now picture the sun is above you and the last layer of the atmosphere or atmosplane is a lot closer to you than the sun. The refraction will happen until the last layer of the atmosplane, which goes to the ground, right? So looking at the sun from the ground through the atmosplane can make the apparent sun appear lower instead of higher. And if you look at it this way, the apparent sun will appear higher, right? But this is all incorrect. What you will see from the ground is the apparent sun only. So whether it appears here or there, it is always lower, and the real sun is always higher. Now the question is, what makes the sun go down as it moves away from you? There are a few theories about this, but they can all be wrong. But let us explain one theory. If the atmosplane is only 5 miles up and the apparent sun is right above it, then yes, perspective can make the sun go down in less than 7,000 miles away from the observer. And this will make the flat Earth model work. But you and I believe that the atmosplane or atmosphere is a lot thicker than that, therefore perspective would help a little, but not a lot. So if the real sun moves to the west for about 4,000 miles, how would the apparent sun look like from the observer's perspective? We can guess, but we will not know until we make a physical experiment that represents all of this. For example, we can do this in a big swimming pool to see how a refracted bulb will look like from far away, in order to see both refraction and perspective in action. If you guys can help, please contact us and let's prove this scientifically. But for now, let's just call it a theory. Because we're just trying to prove it in a 3D program. I'm pretty sure we are correct, but let's just call it a theory. Here is how the real sun and the apparent sun move in Cinema 4D. It's acting exactly how we expected. The apparent sun appears to move faster than the real sun. Therefore, it disappears in less than 7,000 miles away from the observer.
When the apparent sun is at 0 degrees, the real sun is at 35 degrees. And as the real sun rises at its normal speed, the apparent sun follows at a higher speed. The more they rise, the closer they get, and when they are 90 degrees, the refraction is 0.
This is a diagram I made in AutoCAD with the real elevation angles of the sun that we get from suncalc.org. This is the location and dates that I used. You can try that yourself. So when we draw the angles accurately, we notice that the sun travels faster the more it moves away from the observer. As you can see, the distance between 5 and 6 p.m. is a lot longer than the distance between 4 and 5 p.m. And the distance between 12 and 1 p.m. is very close to the speed of the sun on the Tropic of Cancer. On the globe model, you can say it's the speed of the spinning Earth in the Tropic of Cancer. But of course, the apparent sun doesn't travel in a straight line like the real sun does. So the distance between each hour should not be so exaggerated. We can draw it like this, but this is nothing but a diagram. And by the way, if perspective is the reason why the sun sets on the flat Earth, then the more the sun moves away from us, the slower it should appear to us, right? Imagine yourself in the middle of a highway. The cars that pass by you will be moving in their real speed, but as they move away from you, they look like they are slowing down. But that doesn't happen with the sun, right? In fact, the sun appears to travel faster the more it moves away from you. So perspective is definitely not the only reason why the sun goes down.
Here is how the star field would look if we removed the atmosphere. The place is Canary Islands, Spain. The lens that I used here has a 122-degree field of view, and as you can see, the stars never set because they are too high for perspective to make them rise or set. Their altitude now is about 4,000 miles. This number is fairly accurate and matches the rise and set times shown in the programs such as Stellarium. Now I am going to play the same video, but with the atmosphere or atmosplane added. As you can see, the video has changed completely and the star trails look exactly like the original picture. Here is the original taken on March 15, 2015. Now let's play the two videos side by side so you can see the effect of the atmosplane. We can do this from any location. They all work the same. And here is another test in France. Look at it carefully and compare it with the original, and let us know if we're doing anything wrong. And here is how the sun rises and sets in Salinas, California. We still need to make adjustments to the height of everything, but the atmosplane already makes them rise and set correctly. The atmosplane was the key to solving the puzzle.
This is a quick view of the stars in AutoCAD so you can understand how we drew them in Cinema 4D. All the stars you see on the model are 4,000 miles up, and the angles of the stars are accurate and they match modern science. We didn't make them up. And that Excel sheet on the left side of the screen shows all the data that we used. You can find it in the description. Here is a south view of the stars on the flat Earth with the atmosplane added. Now this should be enough for some trolls to see that wherever we are on the flat Earth, the sun and the stars will rise and set. And if they don't look like real life, then please try to understand that by adjusting the map and the height of all the objects in the sky can fix the problem. We still don't know for sure the heights of everything, and we still don't know for sure how the real map looks like. The point is that the atmosphere or atmosplane makes everything in the sky rise and set in Cinema 4D. If you think that the atmosphere should make things go up instead of down, then please talk to Cinema 4D programmers.
Up, and so you get sort of a convex lens of subjective atmosphere that basically follows you around wherever you go. And especially when observing celestial objects which are, well outside of the atmospheric bubble, the inbound light waves coming from such objects are necessarily affected by this bubble, This is what causes the setting and rising of the sun, the moon, as well as the stars. Yes, perspective has a lot to do with it. However, the atmosphere seems to exacerbate or aid in the operations of perspective, allowing the sun to rise and set, the moon and the stars as well. So with that in mind, there's a few other interesting things that happen within the subjective convex lens of atmosphere that surrounds us. So we'll just look real quick at a panoramic view of star trails and the behavior of apparently from a single observational point. And again, this is sort of a time-lapse panoramic view. And if you take something like this, and I'm not saying that we live in a snow globe, what I'm saying is we all live within a subjective bubble of atmosphere that acts exactly like a convex lens. If you take something like this and apply it to, say, a spiral like this, then you get some pretty interesting effects. And just playing with this a little bit, yes, and again, special thanks to Curious J. Check out the YouTube channel. You can see how a convex lens will affect spiral shapes. And we know through either long exposure or time-lapse observation of Polaris that all of the other stars appear to go around Polaris. And there's a big hoopla about southern stars apparently rotating in the opposite direction, although this observation can be seen far north of the equator where the equatorial stars aren't even in view. Although this demonstration here sort of shows you an example of how a convex lens can apparently cause light to do funny things or appear to cause spiral patterns to do funny things. And again, I must reiterate, I'm not claiming that we live within a glass convex lens, but instead we all have a convex lens of atmosphere which follows us around everywhere and would necessarily distort star trail patterns in exactly the manner that we see here, which is fairly consistent with time-lapse panoramas of star trail patterns. And it is oddly reminiscent of a magnetic field, which is also very interesting. But just wanted to share this with you guys because there are explanations for apparent counter-rotation of the southern stars, including but not limited to the subjective convex lens of atmosphere that we all have following us around wherever we go. Also, the magnetic field of the Earth apparently being a magnetic vortex, magnetic vortices, which necessarily display the characteristic of counter-rotational velocities in the centripetal and centrifugal areas of that magnetic vortex. So southern star trails being counter-rotational to those in the north is not exclusive to a sphere, and frankly, without curvature or axial rotation to the Earth, then the Earth could not be a spinning sphere by basic fundamental physical definition. There's no theoretical mathematics needed, just simple observation, measurement, geometry, which literally etymologically means measure the Earth, a little bit of basic physics, and we all can clearly conclude without any sort of doubts that the Earth is certainly not a spinning sphere and is most certainly a stationary plane. And one more final thing to look at, I think it's sort of an interesting observation, but it is claimed by modern science that only spherical objects can cast spherical shadows, although nobody ever told these water bugs or bees on top of the water where their legs make little bitty indentations into the water through surface tension, and just that little bitty indentation in the surface of the water causes a fairly opaque and persistent shadow. And I'm not necessarily saying that space is water, although we do know that the atmosphere is comprised of gases, and gases on the macroscopic level behave as a liquid. And we also know through experiment that lower density gases such as hydrogen and helium tend to find their way up above the troposphere. And I believe there's good evidence to support the notion that such gases concentrated, very cold and condensed layer of hydrogen and helium, which is held in place by the static electric charge of the ionosphere or the magnetosphere itself. So not like a physical barrier in the sky, but an electromagnetic tendency for low density gases to remain within the Earth realm. It has nothing to do with gravity or the theoretical vacuum of space-time. It just has to do with the natural magnetic field of the Earth preventing low-density gases from escaping. And yeah, this would also have nothing to do with any sort of purported physical enclosure, physical glass, structure. So with that, I think I've covered everything that I wanted to cover in this video. Hope y'all enjoyed it. If you'd like to support the channel and help me keep making videos and other efforts, you can do so directly via PayPal to www.paypal.me/themorgile1, or you can become a patron through Patreon for as little as $1 a month, or about 3 cents a day. At www.patreon.com/themorgile. And yeah, this is optional. You don't have to. All of my content is free. Although, should you choose to support the efforts, that's entirely up to you. Thanks so much. God bless you all. Spread the word, spread the world, and peace.